So we will get started here. It is my pleasure to introduce our speaker, Dr. Matt Perzanowski. Over the last 7 years, Dr. Perzanowski has worked closely with our Pass Echo research team here in South Dakota at the Avera Research Institute to better understand the causes of asthma morbidity in the Northern Great Plains. Dr. Perzanowski is an associate professor of environmental health sciences. His research at Columbia's Mailman School of Public Health is exploring environmental exposures that cause the disparities seen in asthma morbidity between lower and higher income communities. He is the principal investigator on the NIH, HUD, and CDC-funded NYC Neighborhood Asthma and Allergy Study, which is examining neighborhood differences in asthma prevalence and persistence to better understand the great disparity in asthma risk between children living just city blocks apart. Dr. Perzanowski completed his doctoral research working with the Olin Group in northern Sweden at the Arctic Circle, where asthma is common, but dust mites and cockroaches are not found. He received his master's in public health and PhD from the University of Umeå in Sweden. I hope I said that correctly. And he has more than 25 years of experience conducting molecular epidemiological studies of asthma and allergy. Welcome, Dr. Perzanowski. We are excited to have you.
Well, thank you, Christine. Thank you for the introduction and thank you for inviting me here. Let me share my screen. Okay. Thanks for the invitation. So I was asked to talk about allergic asthma interventions, which I'm happy to do today. I want to acknowledge before I start that not all asthma is allergic. We think for kids, it's probably a little bit more than half. So there are other drivers of asthma, but allergic asthma is clearly an important component of asthma. In fact, the work that I have been doing with Christy and Amy Elliott here with the PASS cohort has been on some of the non-allergic mechanisms. So I'm not going to focus on that today. I'm going to focus on allergic asthma interventions. I'm going to start off with a disclosure, and this is not your normal disclosure. This is not a financial disclosure, but I think it's an important one to frame the discussion today, so you know a little bit about me. This was a chapter that I was involved in writing for the WHO a number of years ago, and this was the review we received back. So we were writing a chapter on allergic asthma, and we had been admittedly very pro interventions, and so I had written asthma and other allergic diseases are typically treated with medications to control current symptoms and/or prevent future exacerbations. In the field of asthma research, an emerging strategy for reducing or prevention of symptoms is the reduction of allergens in the home environment. Now, that's what I had written, and then you can see what the reviewer wrote in all caps and highlighted. This is the opinion of some believers in prevention, which at best is not substantiated by studies. They usually found that primary, secondary, and tertiary prevention is totally ineffective. And then I had written, given the associations between allergen exposure and exacerbation of allergic symptoms, reduction of allergen exposure is a logical public health goal. You can see the reviewer cross that out in extra large font, in bold, wrote no. So I am going to acknowledge that my scientific conflict of interest is I am one of the believers in prevention. I'm going to walk you through that, though, why I do believe in prevention and why I believe in allergen prevention and why I think it can work, but also walk you through a critical evaluation of why it hasn't worked in many of the studies that it's been done. And then think about what we ultimately need to do from an intervention perspective. Is important to include individual interventions, but probably we need to think larger about community level interventions and policy interventions. So the objectives for today's talk, you'll be able to identify and describe intervention strategies for asthma, including those focused on improved medical treatment and domestic exposure avoidance. And you'll be able to describe, compare, and evaluate the demonstrated efficacy of allergen avoidance as primary, secondary, and tertiary prevention for allergic diseases as defined by the World Health Organization, if I'm successful. So here's an outline of what I'm going to talk about. I'm going to tell you a little bit about asthma, though I imagine many of you know a fair amount about asthma. Talk about the WHO prevention definitions, then start with tertiary prevention for symptoms and acute medical visits. We know a lot about that. And then move into allergen interventions. What's the motivation for doing allergen interventions? Why do we think it should work? Why am I a believer? Tertiary preventions and then primary preventions last. And then we're going to talk about the need for community level interventions. Okay, so let's start off with asthma. So asthma is bronchoconstriction. This is a cross-section of the airways. You can see in red the smooth muscles that are wrapped around the airways. With bronchoconstriction, you have a relatively quick response that causes the airways to narrow, and it makes it difficult to get air in and out of the lungs. Asthma is also an inflammatory response. So you have what's called the late phase inflammatory response with asthma, and that is that you have this immediate response within a few hours, but then within 4 to 8 hours after exposure, you get infiltration with cells, inflammatory cells that are going to lead to more inflammation, and essentially they make the airways more twitchy, right, so that they'll respond to other stimuli more easily. We know there's been a large increase in asthma that started somewhere in the mid 20th century. And this is a study from Finland where military service is mandatory. This is among men, just showing a clear increase in prevalence of asthma starting in the 1960s, starting in the mid 60s, going through the year 2000. We don't have this kind of data, this national prevalence data in the United States, but through various ways of prevalence data, we know that the asthma has increased in the United States as well. We also see that asthma varies across communities. And so I've been working in New York for 20 years and was really struck by a version of this map when I came to New York. When I was doing my PhD work in Sweden, one of the ideas was, because asthma has been increasing differentially across different countries and different communities, that potentially we could do work and compare different communities to understand the reason for the increase in asthma. So I was doing work in Sweden. I had been involved in a project in Kenya where asthma prevalence is very low, and then also in Atlanta, Georgia. And the truth is that you try and compare what environmental risks are different for kids in Kenya versus Sweden versus Atlanta, almost everything is different, right? From dietary exposures to environmental exposures. And so it's very difficult. So that's why I was struck by this map in New York City. And we've spent the last 20 years trying to investigate reasons for these disparities in asthma. So just for those of you who aren't familiar with New York City, one, I'm only showing you 4 of the 5 boroughs. This is Manhattan, the Bronx, Queens, and Brooklyn. And you'll see that asthma prevalence among 5-year-olds, so this is prevalence, not hospitalizations or emergency room visits, just prevalence, ranges from around 3% in Flushing, Queens to 19% in East Harlem. I'm not sure if you can see my arrow here, but this is East Harlem here, the darkest red there. And what I want to draw your attention to is just below that is a neighborhood called the Upper East Side. So East Harlem is one of the poorest neighborhoods, and the Upper East Side is one of the wealthiest neighborhoods. And you can see that there's a difference in asthma prevalence that's almost 3-fold between those two communities. So, and then when we look further, so that's asthma prevalence. We look at emergency room visits, and here I have those neighborhoods labeled again: the Upper East Side on the lower, with the lower poverty index and lower emergency room visits, and East Harlem with about a 10-fold increased risk for emergency room visits between these two communities. So we see large differences even within one city, within one community, in asthma risk and asthma prevalence. So I'm going to talk about this in the construct of what's been called the atopic march, and I've modified it a little bit to think about these different components of asthma morbidity. And I think these are important when we're talking about interventions. Where are we intervening, and what are we trying to do? So we know there's a genetic component to asthma, and that for many individuals, as I mentioned before, there's allergic and non-allergic asthma and other phenotypes within those. But we're going to roughly think about those two, mostly allergic asthma today. You need to develop allergic sensitization. I'll talk talk about that in a few minutes. And then for those who develop allergic sensitization, some will go on to develop asthma. And then among those, some will have asthma attacks. When we think about further components, the unscheduled medical visits for asthma, emergency room visits or physician visits, and then ultimately hospitalizations being the worst in this, well, mortality and hospitalizations being the worst here. And so why I'm showing you this is that we know that environmental exposures are important at all these steps, as well as things like access to healthcare, appropriate medications, which can prevent symptoms and worse exacerbations. And so when we're thinking about interventions, it's important to know, what are we talking about intervening on? Are we trying to prevent the development of allergic sensitization in the first place? Are we trying to prevent allergic asthma, or among asthmatics, are we trying to prevent asthma attacks? Are we trying to reduce unscheduled medical visits? Because the environmental intervention that we're doing, or the intervention more broadly, needs to be tailored to those to the prevention. And feel free to put questions in the chat. I think I can see the chat here. If you have questions along the way, or just interrupt me, I'm happy to answer questions. Okay, so that's asthma. Let's move on to WHO prevention definitions. Right, so this is our atopic march, and I have this for urban asthma, but this is also for asthma in suburban and rural communities. Primary prevention, as defined by the WHO, is the prevention of allergic sensitization in the first place. Secondary prevention is the prevention of allergic asthma and non-allergic asthma, and tertiary prevention is the prevention of asthma attacks, unscheduled medical visits, and hospitalizations. So let's start off with tertiary prevention. We know a lot more about tertiary prevention. We've done many more studies on tertiary prevention than primary or secondary, and when we know quite a bit. These are those you probably are aware of a lot of our intervention strategies. So short-acting bronchodilators are very effective in reducing symptoms. We also have things like inhaled corticosteroids or other ways of longer-term prevention of asthma symptoms in the first place. Reduction of the allergic inflammatory component is important. And the lower corner there, we have that's an electron micrograph of dust mite covers. We'll talk about those a little bit more, but you can see there's a dust mite there. So we have these environmental interventions that we can do for tertiary prevention. And then lastly, you have a child with a peak flow meter. So we know that monitoring symptoms is a good way to control, to work towards having appropriate therapy to prevent exacerbations and worsening of disease. There's been quite an effective intervention plan with asthma action plans. So these have been done in primary care settings or through school settings, where you get kids with probable asthma symptoms hooked up with a physician to get an asthma action plan. Essentially, this is for parents or caregivers to be able to monitor their children's symptoms and know what to do when their child is having an exacerbation. And this has been effective in reducing symptoms among those who are undertreated or those who are undiagnosed, and by definition undertreated. So these school-based plans, have been a number have been done. We've been seeing some of them here in New York City be effective. So this is a study that Jean-Marie Bruzzese and Meyer Catan and David Evans were involved in. They screened use of schools to identify undiagnosed and untreated children. They used questionnaires to identify these kids, and then were able to send them to get treatment and to get an asthma action plan, and that ultimately reduced in their symptoms. So those are the known tertiary prevention. That we know those are effective methods. Those are important in how we treat current asthma. But also, I want to talk to you more about environmental exposures and environmental interventions, what we potentially can do to augment those other interventions. So for those of you who don't know, an allergen is a substance. It's usually a protein. It's capable of inducing allergy or specific hypersensitivity. IgE antibodies are the ones that are involved in allergy. They're made to things like dust mites, cockroach, cats, mice, to pollen, all sorts of things. We measure allergic sensitization either through a skin test or measuring IgE antibodies in serum. The skin test is a really effective method in the clinic because it allows you to show individuals what they're allergic to. They respond relatively quickly within 5 to 10 minutes, similar to a mosquito bite. Also, though, we can assess in the lab and measure IgE, and those methods correlate fairly well. So I said I'm a believer of interventions. Why am I a believer? Why do I think interventions can work? Some of it comes down to a work I'm going to show here. So this is an old study. It was a pollen study. It essentially took individuals who were allergic to pollen and monitored symptoms, and some of them received a medication. Medication is important. Essentially, it shuts down the allergic response. But what I wanted to show you is that on the top here this is going from April to September. These are the number of grass pollen counts in the air. And so you can see it goes from pretty much 0 to really high counts in June, and then drops back down to almost 0 again at the end of the summer. And you can see for the individuals in the figure below, those symptoms increase during that same time, peak at the same time, and then decrease after that. And the medication that was used to treat it decrease some of those symptoms. So, and then on the right, I have a figure of several urban communities in the United States where they enrolled kids who had asthma, and they went to their home, collected dust samples, and measured cockroach allergen. And they also skin tested or measured IgE in the kids to know if they were allergic, and grouped them into 4 groups. Based on sensitization, in other words, their allergy, or whether they're exposed to cockroach. And the first group are not exposed and not sensitized. The second group are exposed but not sensitized. And the third group are sensitized and not exposed. The fourth group being sensitized and exposed. And they looked at unscheduled medical visits for asthma. And what they found were unscheduled medical visits were about twice as common in the kids who were both sensitized to cockroach and exposed to cockroach. So why do we believe tertiary prevention can work? Well, mostly it's from the figures on the left, right? That if we reduce allergen exposure, we see a decrease in symptoms. Now, the caveat to this, the challenge of this is, can we really, in the real world, reduce cockroach exposure down to a sufficient level, or dust mite exposure down to a sufficient level where exposure is low enough that you're not getting symptoms? We don't think we can bring it down as low as the grass pollen. I don't think we can bring it down below to 0, with the exception of moving to a place where you don't have dust mites or you don't have cockroaches, meaning to a place where the climate doesn't support that. But still, this is compelling evidence for tertiary prevention. One of the things that's important to think about also in prevention is getting rid of the allergen source as well as the allergens in the environment. So this is a study that I was involved in a long time ago. It was a cockroach intervention. It didn't have a health component. It was just to reduce cockroaches, ultimately to inform our health interventions. And we went into these homes, and there was an intervention, a chemical intervention. And when we did that, we also put sticky traps down to collect cockroaches and collected dust samples to measure cockroach allergen. And you can see on the left, and this is kind of a scary y-axis to look at, these are the number of cockroaches that just happen to crawl across these small sticky traps. You can see they're in the 40 to 80 range as the number of cockroaches peak. And then on the right, in the line with the square, is cockroach allergen. It's an allergen called Allergy. It comes from the cockroaches. It's primarily found in body parts and fecal matter. It is the actual allergen that people respond to. So if you have IgE antibodies to cockroach, you have it to Allergy, as well as some of the other allergens. So it's a really good indicator, not only of are there cockroaches around, but are there relevant allergens around. And what you'll see is with this figure is the intervention went pretty well. We reduced the cockroaches quite a bit. However, the allergen still stayed high 2 months later. And you can see it slowly reduced over time. But the important thing is that while this intervention worked to reduce the cockroaches, it didn't work to clean up the reservoirs where these allergens were found. So the dust in the homes, where the cockroach body parts still remained, and other parts from the cockroach where you still have the allergen. So it's important when we think about these interventions to make sure we're not just getting rid of the source of the allergen, but or the initial source of the allergen, the primary source of the allergen, but also getting rid of any residual allergens or other things in the environment that could be causing symptoms. Okay, so that's our motivation. How has tertiary prevention worked? Well, so some of the things we've used for tertiary prevention, probably the most well-studied, are dust mite covers. So dust mites are just microscopic. They live in bedding, they live off of skin scales, and they take in water from the air. That's why in very dry environments, you don't find dust mites, because once you heat the air up to room temperature, comfortable room temperature, it's very dry and doesn't support dust mites. It's why one of the reasons I was doing my PhD in northern Sweden, we were doing research studies because asthma was relatively common there, but there were no dust mites because the air was so cold. Dust mites are also not very common in South Dakota for similar reasons, because once you heat the air up in the wintertime, it becomes very dry and dust mites are not as common. However, dust mites are common in many other places, and it's been one of the reasons for large interventions on these allergens. Okay, so back to this, I'm a believer, and the reviewer of the chapter we wrote for WHO is clearly not a believer. What are our respective evidences? So what that person's going to show you is the figure on the left. And that's admittedly our highest form of scientific evidence. It's a meta-analysis of randomized controlled trials. And these are tertiary prevention studies of allergic disease symptoms and dust mite levels in mattresses. And so on the top, you can see that the meta-analysis of the symptom scores is no. You know, the overall effect, the black diamond there falls in line with 0 with unity, so no effect. So when we look at the dust mite levels in the mattresses, they were able to reduce them. Now, so that's the evidence that person's going to show. What's the evidence that I'm going to show? I'm going to show you this figure on the right. And this was a large study from the mid-2000s where they did a randomized controlled trial of allergen interventions. It was a home-based environmental intervention among urban children with asthma. And you can see that, well, we saw a decrease in symptoms in both the controls and the interventions, which we almost always see a decrease in symptoms for among the controls in these type of trials. The decrease in symptoms was actually greater for the intervention group. And this intervention is actually pretty substantial. It's similar to what you see for inhaled corticosteroids. So why? What are the differences between that meta-analysis of all those different studies and this particular study what else were they doing? Why were these studies not working before? And so one of the reasons was that specific allergen sensitization wasn't always being determined and specific allergens targeted. So if you're targeting someone for 6 different allergens in their environment and they're only allergic to one of them, you're wasting a lot of time. You're wasting their time and possibly the effectiveness of the intervention. If they're only allergic to dust mites, you only need to be intervening on dust mites and you don't have to worry about cockroaches or cats or other things. But that said, all of the relevant allergens should be targeted, as well as other triggers, and that includes tobacco smoke. So if you're doing an intervention to reduce cockroach allergen, and they're also the kids are allergic to dust mite, and there are dust mites in the home, the intervention might not be effective. Also need to think about multiple domestic locations being targeted. So it's not just the beds where the dust mites are found, carpets, fabrics, upholstered furniture. The amount of allergen reduction required for a clinical effect is unknown. So we can't set thresholds and say that this is the level of allergen intervention you need to be able to reduce exposure. So ultimately, that's what led to this study being effective, is that they allergy tested the kids. They went to their homes, collected dust samples, measured allergens in those homes, and were able to show, then targeted, tailor the intervention for the families to reduce only those things that they were allergic to. They included tobacco smoke. And then they trained the families to be able to have a consistent reduction of these allergens. In other words, if cockroaches were the problems, they trained them in integrated pest management to reduce cockroaches, not just at the intervention time period, but effective methods for keeping cockroaches out going forward. Okay, so that's tertiary prevention and why we think allergen interventions should work for tertiary prevention. What about primary prevention? Okay, so going back to primary prevention, we are looking at here the prevention of allergic sensitization in the first place. So why do we think primary prevention can work? So I mentioned, Christy mentioned that I did my PhD in northern Sweden. So I was in northern Sweden because we were very interested. Asthma prevalence is around 10% at the time, which was not the highest in the world, but it was relatively high. And we were interested in understanding about environmental exposures there. And so this is in a town called Jukkasjärvi, north of the Arctic Circle, where they build an ice hotel every year, actually quite famous ice hotel. People travel from around the world to go to this ice hotel. And this is the playground at the school near the ice hotel. And so the sculptors had come and made some sculptures for the kids on their playground. But it's cold and it's snowy and it's and the air is very dry. And so when you heat that air up, it's dry enough so it doesn't support dust mites. So we had skin tested kids, all the kids, or 88% of the kids in 3 of the towns in northern Sweden. So about 2,000 kids. We skin tested them to inhalant allergens, including birch, timothy, as well as cat and dog. The D. terranicinus and D. farina are dust mites, and then some molds. And what we found were, the kids were very commonly allergic to cats and dogs, horses, but they were not allergic to dust mites. In fact, there was a little bit of transient sensitization, which I'm not exactly sure why, but very few of them were allergic to dust mites. So in terms of primary prevention, we know that you have to have the allergen around. So if we could reduce allergen exposure to low levels, like we see in Sweden, could we then reduce the development of sensitization in the first place? So this has been done with mattress covers, looking at primary prevention for preventing allergic disease. And you can see for sensitization, meaning were the kids allergic to dust mites, the overall meta-analysis showed no effect. When you looked at asthma, however, there was a modest protective effect on the development of asthma. However, that was really driven by 3 of the studies. And these studies not only included environmental interventions, they included other components. So there's a study in the Isle of Wight. They also they had reduced asthma and dust mite sensitization, but they had dietary changes as part of their intervention. In Manchester, England, they had improved lung function measured at age 3. However, they found that there was actually increased dust mite sensitivity, possibly related to some of the other exposures that they had reduced. Then the CAP study in Australia, they showed reduced asthma, especially among girls, but there was no impact on allergic sensitization, and their intervention also included dietary modification. So in terms of primary prevention to prevent allergic sensitization in the first place, we haven't been effective in preventing sensitization. Some of the studies seemed to prevent asthma, but they didn't only include an environmental intervention. They included other components. So I would say for primary and secondary prevention, we haven't shown that allergen interventions is effective. For tertiary prevention, the results are mixed in the literature. I think there's some evidence that it should work and that it can work when individuals are targeted based on their sensitization and their exposure. Any questions before I move on to community level? Feel free to put anything in the chat. Try and monitor that as we're going. So spending years doing these interventions, being involved in the interventions and exposure work and working with community groups and trying to understand how we can better intervene, it seems to me that we need, while the individual level interventions are important, we need to think about community level interventions. So back to New York City, I showed you this on the right. I showed you that map before of asthma prevalence and the wide variation in asthma prevalence. On the left, I've got 2 figures. One were residents, what was the frequency of residents reporting cockroaches? And then below it, what's the frequency of residents reporting rodents? And you can see that those neighborhoods with high asthma prevalence are also the ones where we have high cockroach allergen and high rodent allergen. And so we know that and if I were to show you a map of poverty, that would look similar in neighborhood level household income would look similar, inverse with income and asthma prevalence. Higher income neighborhoods, lower asthma prevalence. In New York City, one of our studies of about 700 families, we asked, how often do you see cockroaches in your home? And they could answer never, rarely, weekly, or daily. And at the same time, we had collected a dust sample and we brought it back to the lab and we measured cockroach allergen. And what you can see is this is highly significant. You know, as you go from never to daily, you get a much higher mean cockroach allergen and those reporting daily cockroach sightings, and much lower in never. And the other thing I have to tell you about in New York, having lived in a number of different places, in New York City, cockroaches is something we just deal with. So there's less of a stigma about reporting cockroaches. In many other communities, there's a stigma about reporting cockroaches. Here, we admit it. It's a problem. We deal with it. We try and get rid of them. But so there's less of a stigma there. So I think we do believe this report of how often people are seeing cockroaches. And so while we see big differences between the groups, it's also clear that in some of those who are reporting never seeing cockroaches, they have pretty high levels of cockroaches. So either they're not noticing them, or the allergens are coming from another apartment. You know, that some of these allergens can travel in the dust and move between apartments, and so there may be exposure in places where we think that don't think that you have high levels of exposure. And so before I go into that slide, so one of the important things here is, can we think about ways to reduce cockroach exposure at larger communities? And part of the problem here too is that for many individuals in urban communities, they live in multifamily buildings, in large apartment buildings, where they may be able to control what's going on in their apartment. But if their neighbor's not taking care of their own apartment, the allergens, the cockroaches, the pests, the mice, those can still then end up leading to exposures happening in their own apartment. So what have we done? Well, New York City Council passed a bill to protect tenants from mold and pests. Essentially, this empowers, it's called the Asthma Free Housing Act, and it's meant to make it so that the renters of apartments are guaranteed that their landlords need to take care of asthmagenic pests. So mold, cockroaches, mice, other indoor health hazards. Another problem we've had that we know is associated with asthma and is something the community groups talk about. What we also know from an Institute of Medicine report, many meta-analyses, is that mold can lead to asthma exacerbations. Part of this is through an allergic, at least part of this is through an allergic reaction. There may be other components of mold that lead to asthma symptoms, but it's definitely, there's an allergic component. And so here again, I'm showing you in New York City, the map of asthma prevalence, and then also the map on the left side, the map of homes reporting leaks. Primarily mold comes from water, excess water in homes. And so because we all have mold spores around, if you have excess water, those things will start to grow. And so homes with leaks are ones that'll start to grow mold. And you can see that the homes with leaks are more common in neighborhoods where the asthma prevalence is also high. And so, interestingly, there was a lawsuit about a decade ago where National Resource Defense Council, NRDC, sued New York City Housing Authority. That's the public housing, all of public housing in New York City. It houses about 400,000 residents. And so they sued them under the American Disabilities Act because asthmatics are protected by the American Disabilities Act, to have NYCHA that's a public housing authority, start to treat mold in a different way, to take it more seriously, and to start to reduce mold in residents' homes. And what that led to was a program they rolled out recently called Mold Busters. And so this is all of public housing in New York City, a large population. They're using better tools to find mold in its causes. They have enhanced the training for the maintenance and supervisory staff. They've moved to being more accountable through inspection systems and software to be able to keep on top of these mold reports and the remediation. And they have a streamlined response, and they're also creating a new information tool to be able to communicate with the residents and find these mold sources and reduce them. So this is just started in 2019, and then obviously COVID interrupted some components of this. We are partnered with NYCHA to evaluate this and with the New York City Department of Health to see whether this has an impact on asthma emergency room visits in New York City, because again, it's a really large population. Another thing we know works well, or has been demonstrated in studies, are community health workers. This works in low-income communities. It's been demonstrated in other communities as well. So we're thinking about in rural communities too. And there have been randomized controlled trials in asthmatic children, as well as adults. And they've seen that having community health workers go into homes leads to decreases in asthma triggers, including allergens. It leads to improvements in symptoms and reduction in urgent health services. And in adults, it led to improved symptom-free days. Not unscheduled medical visits, but it did lead to improved symptom-free days. And so we think that use of a community health worker in lower income communities could be effective. And that's something we can think about from a community level intervention. So another exposure to talk about in New York City, but also relevant in many other communities, is combustion byproducts. And this is the particulate matter that comes from combustion.
Hi, is this Courtney?
Oh, hello?
Yeah, Dr. Roy here. I'm good. I hear things aren't going well at your place.
So I think we've got someone who maybe could mute.
Yeah.
Yeah, thanks. So black carbon is the combustion particulate matter that comes from, think about diesel exhaust. So a diesel truck, you see black soot coming out of the top of it. Other components are, any kind of burning of fossil fuels leads to soot. And so in New York City, we see the map is not as convincingly associated with asthma prevalence. You can see that some communities, some neighborhoods have higher black carbon where they don't have a high asthma prevalence. But we know that this can lead to help lead to increased risk for sensitization, so in a bad way, and also lead to all components of the allergic response after that. And so we think it's an important thing to intervene on. In New York City, the major sources of black carbon were on the right there, you see truck routes. So that's a major truck route. My apartment for 8 years was literally 50 yards to the right of that. So many of us live near major truck routes where you have diesel exhaust. And so this was part of a study where we put air monitors in homes of kids and then measured black carbon over the next week. And so that's our y-axis there. And though here on the right, what we did is we looked at the truck density, the amount of truck routes in the 500 meters around the child's home, and see a pretty strong correlation between black carbon from truck routes on the right there. On the left, though, what I'm showing you is buildings burning what's called residual oil for heating. So New York City has a history of being a port city. So we refine oil here near or close by. And so with that, we have had exempted using fairly dirty oil for heat for a long time, and including the burning of number 4 and number 6 oil. Number 6 is not a liquid at room temperature. It's very heavy, viscous, very dirty oil. And so if you come to New York City, you see it less now because of something I'm going to mention, but you would see up until just a few years ago, you see these big black plumes of smoke coming out of homes. And that was this residual oil being burned to heat water for radiators. And so same thing, when we drew a 500-meter circle around children's homes and measured black carbon, we saw a pretty strong correlation between the number of buildings burning residual oil and the black carbon we measured in the child's home. So, but that leads us to the potential for an intervention. So this is the residual oil. The New York City Clean Heat Initiative, which was enacted about a decade ago, banned number 6 oil by 2015 and has banned number 4 oil by 2030. And so we're already seeing large decreases in the particulate matter, specifically black carbon, in New York City across the city. And this is exciting because we think that this is one of the drivers of asthma. Potentially cleaning up the air in the city in general would reduce asthma exacerbations. And so to support that, some exciting work out of California. So in California, they've done a number of cohort studies of children to look at asthma and over time. And what they found was that because they've done studies all the way back to the 1990s through the 2000s, over that time, the air has gotten cleaner in California in general because of interventions. And what they found was over that time, as these different cohorts of kids, their lung function was better. The kids who were born in these later cohorts where asthma, born in these later cohorts where the air was cleaner, were more likely to have better lung function. Other interventions that we've seen, community interventions, in New York City in public housing, or actually public housing across the country, smoking inside buildings was banned. That includes smoking inside a resident's apartment in someone's individual home. Obviously, some controversies around that, but that has led to decreases in smoking in buildings, which will lead to decrease in exposure to individuals outside of those apartments, as smoke can seep underneath doors, as well as go from common areas into homes. Another area of exposure to think about is the school. This is a study that not that I did, but it was going on in northern Sweden, or in Sweden when I was there. So in Sweden, what we found is there are no dust mites, but cats are really important for asthma. So many of the individuals who have asthma, kids who have asthma, are allergic to cats. But what we had seen was the owners of cats are less likely to develop asthma and allergy. And so this was a study that looked at kids who didn't own cats in their home, but were allergic to cats. And what happened after coming back from their vacation, their summer vacation. And so these are allergic kids coming into the classroom. And then in yellow, those are the kids who are coming to classrooms where there aren't very many cat owners, less than 18%. And in red, those coming into to classrooms where many of their peers had cats. Now, there are no cats in the classrooms. Cat allergen can travel really easily on clothing. So if you are someone with a cat or a dog, you pick up those allergens, you bring them to your workplace, to any public place that you go, and you leave some of those allergens around. So we can measure cat allergen almost in any public space. And what this was showing on the left, those are peak flow symptoms. So the larger the decrease in peak flow, the worse off the kids are. And then on the right in symptoms, the larger the increase in symptoms, the worse the kids are. And you can see that the kids with less than 18% cat owners in their class really didn't have a significant difference when they came back, if anything, an improvement. And whereas the kids who are coming back, who are allergic to cats, coming back into classrooms where many of their peers own cats, then you see a decrease in symptoms. So, and then in New York City, what that looks like is we went and measured mouse allergen in dust samples, and we're able to see that a majority of the samples that we measured allergen in had mouse allergen. Now, the mouse, unlike the cat story, the mice do live in the schools, and we know that's an important target for interventions. But then lastly, on this story, this is a study that Will Sheehan did in Boston, showing mouse allergen in the school. So this is mouse allergen in the schools, not in the homes. And with increasing mouse allergen, the kids had increasing symptoms on the left and decreasing lung function on the right. So decreasing lung function is bad for asthma, more likely to have symptoms. And so what this is showing is adjusting for home allergen levels, the school allergen levels are potentially really important. And so as you're thinking about interventions, designing community level interventions, you probably also want to think about the school as an important location. The last thing I'll just show is the importance of stakeholder engagement in developing patient-centered pediatric asthma interventions. So this was a really interesting study where the researchers involved had some ideas about what they thought they should do for the research study, but they involved community members in designing the study, and which led to some changes. So while initially the researchers wanted to have a primary outcome of inhaled corticosteroid adherence, so sticking to preventive medications, the community thought it'd be much more impactful to look at symptom-free days, something that the individuals are going to be able to see more easily and see as an important point. The researchers thought they should use social workers and psychologists, whereas the community group thought that community wellness coaches would be better in conducting the intervention study. And then lastly, the intervention from the researcher's perspective should include problem solving and parenting skills, but the community members thought that it should also include mindfulness, positive thinking, self-care, and how to teach these skills to children. So the case I'd like to make is that the community level and policy interventions could help address some of these challenges that individuals face. Aside from administering environmental interventions through primary care clinics and allergy clinics, we can assist in where we have higher burdens of asthma, reducing some of these allergic asthma by So some of the challenges are individuals being unaware of exposures or exposures that happen in other homes, families not being able to fix structural damages that contribute to pests and mold. Tobacco smoke exposure is difficult to reduce. Community level combustion exposure is not something that individuals can reduce very easily. Exposures outside of the home are important. And so some of these things can be addressed by building-wide, it's like public housing-wide interventions, legal resources to force landlords to remove pests, building-wide bans on smoking, community reduction in combustion exposure, interventions targeting schools, and a better understanding and addressing of the needs through community-based participatory research. So just to summarize, appropriate medical therapy, including proper prescriptions and use of medications, avoidance of triggers, monitoring symptoms and lung function can reduce asthma symptoms and acute medical visits for exacerbations for hospitalizations. While allergen avoidance should work, and again, I'm still a believer, for tertiary prevention symptoms, their literature is mixed and not all studies have demonstrated efficacy. I think I walked through some of the reasons why I think they may not be effective and what we can do to improve that. It's probably due to insufficient avoidance measures overall. Allergen avoidance as a primary prevention is yet to be demonstrated as effective in preventing asthma. Ultimately, we're probably going to require additional preventative measures, and community level interventions may be necessary for individual level interventions to be effective. So with that, I will stop sharing and be happy to take any questions. Thanks, Amy. So Amy put in the chat, do we know what it is about cockroaches that could increase asthma exacerbations? You know, it's interesting. We don't know what makes an allergen, but we know that individuals commonly respond to the same proteins. So if you're allergic to cat and I'm allergic to cat, 95% of our IgE antibodies are to the same protein. And similar for cockroach, the people tend to respond to the same proteins, and we don't understand exactly why why we're allergenic, but it's clear that it's an aberrant response. It's not a response that's helpful for us. While it seems like we don't like cockroaches, they seem gross, making an IgE response is not something that helps us in any way. And so it's not clear why we make that response. You know, one of the things I didn't talk about is, you know, when we think about the reasons for the increase in asthma, one of the primary hypotheses around it over the past 20 years has been something called the hygiene hypothesis. And it's this idea that we live much cleaner today than we did 100 years ago. And that's what led to this increase in allergy. And you see things like birth order. So if you have older siblings, you're less likely to develop allergy and asthma. Exposure to some microbes in the home, more bacteria, like non-pathogenic bacteria, is protective. And so it's likely that that's part of what's going on. But in terms of interventions, you know, none of the primary preventions. There have been some, you know, modest effect in secondary outcomes with things like probiotics, but nothing along those lines has been really effective in primary prevention.
So Matt, following up with the great presentation, thank you. Following up, I actually had a question about the hygiene hypothesis and how that kind of plays in with kind of, you know, allergic asthma. So have there been interventions looking at that, you know, exposing folks to some set of maybe not allergens, but, you know, germs and such, to kind of actually use that as an intervention?
No, not that I'm aware of. I've seen, so another place we see is, I mentioned the pet protective effect. We see that kids that grow up with cats and dogs are less likely to develop allergy. And that the mechanism is not clear. That could be through a really high allergen exposure, or it could be through microbial exposure, something in line with the hygiene hypothesis. And over the years, I've seen a few proposed interventions with cats or dogs, but none have been approved or have been done to my knowledge. The probiotic studies, again, sometimes they'll show a modest effect that then they don't observe later, 5 years later, or it'll be in a secondary outcome, but nothing has been really proven. And I don't know, we don't really understand what it is about is it healthy communities that prevent out bad actors, or is it really something along the lines of priming the immune system in a way that's non-pathogenic that then protects against the development of allergy.
Yeah, and then in one of your first slides, you had talked about kind of that genetic predisposition as well. And so then, is it epigenetics that kind of turns on or turns off some of those things with those interventions? Have you looked at anything like that?
So I know some studies have looked at potential epigenetic changes, and I think seen some modest associations. Whether the increase in asthma, obviously over 2 generations, is not a genetic phenomenon, although we know that there's genetic susceptibility in a number of different genes. So like there's not one gene, but many different genes have shown increased susceptibility to asthma. But yeah, an epigenetic mechanism is possible. The other thing that's hard to sometimes disentangle, is the environmental exposures that are the same. And so that if a parent is growing up in a community with a certain kind of allergens, their child may also. And so that's difficult to disentangle. But epigenetic mechanisms are potentially an interesting way to understand this better.
Great. Does anybody else have any other questions? You want to put them in the chat or raise your hand or. So it looks like Paula has a question in the chat. Matt, is there any indications that sensitivities to one allergen makes an individual likely to form sensitivities to other allergens?
Yeah, what a great question. Yes, and in general, we think of the definition of atopic is a predisposition to developing allergy. And so we think that individuals with that predisposition will develop to allergens that are around them. We also see that sometimes individuals will develop to like a primary allergen like dust mite, and then will develop to other allergens around them as well. We know that being multi-sensitized, not surprisingly, it does increase your risk for having asthma exacerbations or more frequent asthma exacerbations, although some primary allergen exposures like dust mite are also been shown to be strong risk factors for asthma. So yeah, developing allergies to one does make it, you're more likely to develop allergy to others. And that's why you get a phenomenon where people who have hay fever will move to a different region of the United States, and their symptoms will go away for a couple of years, but then they'll start to come back eventually once they develop allergy to the allergens around them.
Great. It looks like we don't have any more questions. Well, thank you very much, Matt, for taking the time. It was a great presentation, and I hope everyone has a great rest of the week.
Yeah, thank you. And
you,
if anyone wants to follow up by email, happy to discuss further. Thank you.
Have a good day.